Hello, myself Nirmala, working as Assistant Professor in St. Joseph's College of Engineering, Department of EEE. Today, I am going to discuss about DC motors, its basic principle. Its basic principle, then back EMF, then types of DC motors, characteristics of DC motors, finally about speed control. So first one, what is a DC motor? It converts electrical input into mechanical output. It is similar to a DC generator, only thing the input is changed. If you give electrical input and you get mechanical rotation as output, then it is called DC motor. Since this machine works in DC supply, that's why we are calling it as a DC motor. So the basic principle of a DC motor is whenever a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. Say for example, here you are having a magnets and in between you are placing a conductor. So the field above the conductor will be weakened, whereas the field below the conductor will be strengthened. So what happens? Due to this, the conductor starts rotating. Okay, so the basic principle of a DC motor can be explained by Fleming's left hand rule. So if you stretch out your forefinger, thumb and middle finger perpendicular to each other, if the forefinger points towards the direction of current and middle finger points towards the direction of magnetic field, then the thumb points the direction of force. I am one more time I am repeating. If we stretch out the forefinger, middle finger and thumb of left hand perpendicular to each other, if forefinger points the direction of magnetic field and middle finger points the direction of current, then thumb points the direction of force. So the same principle is used here. So the motor works by the principle of Fleming's left hand rule. Then we have to discuss about back EMF or counter EMF. So back EMF is nothing but it opposes the applied voltage. In a motor, we are giving electrical input, so voltage is applied. So in that, the conductor starts rotating. Due to that, you have a voltage that opposes your applied voltage. So when the machine works as a motor, the voltage induced in the conductors opposes the applied voltage. That is called back EMF or counter EMF. And back EMF is given by EB equal to P phi Zn by 60A volts, where P is number of poles, phi is flux per pole in Webers, and Z is the total number of conductors, N speed in RPM, A is number of parallel paths. So this is the basic equation of back EMF. And then what is the voltage equation of a DC motor? So since here we are applying voltage here and we have a shunt motor, consider here we are having a motor and we are supplying DC supply and here motor is there. So the voltage equation is given by, here you have a back EMF. So EB plus IA or A, where V is the voltage applied, EB is the back EMF, and IA or A is the drop across this armature resistance. FF represents the field winding. This is the voltage equation. So voltage is the summation of back EMF and the drop across the armature resistance, IA or A drop. Here the power equation can be obtained by multiplying current with the voltage. So V into IA equal to EB IA plus IA square or A. So this is called power equation of DC motors. Next, we have to discuss about types of DC motors. So motors basically classified in general into two types. One is separately excited, another one is self-excited. In separately excited, if the field winding is separately excited from DC supply, then it is called separately excited motor. So in separately excited, here it is the field winding, it is separately excited from a DC source. That is called separately excited motor. And for armature, we will be giving separate supply. So consider it as a motor. So this is called separately excited motor. Here the field winding is separately excited from DC supply. Armature separately the voltage is given. So if the field winding is separately excited from DC source, then it is called separately excited motor. Next is self-excited motor. In self-excited motor, here we have different classification. One is series motor, shunt motor, then compound motor. So first one, series motor. If the field winding is connected in series with the armature, then it is called series motor. Say for example, in series motor, so in series motor, we have few turns of thick wire that is called series field winding. It is connected in series with the armature. Here IL is the line current and I series is equal to IL. IL is equal to I series equal to IA, because in series connection current remains same. So the line current IL is same as that of series field current, that is equal to armature current. So here why we are calling it as series motor means the field winding, a few turns of thick wire that is connected in series with the armature. That's why we are calling it as a series motor. And regarding voltage equation, here we have a back EMF EB that opposes the applied voltage. So we can write the equation as V equal to EB plus IARA So here we have V equal to EB plus IARA. Then we have I series into R series. Then we have the brush drop. So this is the general equation of a series motor, voltage equation. Here we have the back EMF EB, which always opposes the applied voltage. So V equal to EB plus IA into RA, that is armature resistance drop, plus I series into R series, that is the series field drop, along with the brush drop. Here we have considered IL equal to I series equal to IA. I can replace this by IA. So I can write it as V equal to EB plus IA into RA plus R series plus brush drop. Usually we have brush drop of 2 volts because we have 2 brushes. So each brush has a drop of 1 volt. So we can consider the brush drop as 2 volt. Even if it is not given, we can consider the brush drop as 2 volt. So the next one is shunt motor. In shunt motor, why we are calling it as shunt motor means the field winding is connected in parallel with the armature. That's why it is called shunt motor. Here we are giving a voltage of V volts and the motor and here we are connecting the shunt field winding. So here the current will be IL and it is divided into 2, that is armature current and shunt field current. So the total current is IL and it is getting divided into 2, armature current and shunt field current. Why we are calling it as shunt motor means the shunt field winding is parallel with the armature, the field winding that is connected in parallel with the armature. That's why we are calling it as shunt motor. Now, regarding the voltage equation, we can write V equal to the back EMF EB that opposes the applied voltage EB plus IA RA. Since these two are in parallel, so the voltage remains same. So EB plus IA RA plus the brush drop. Regarding the current, according to Kirchhoff's current law, the incoming current should be equal to the sum of outgoing currents. So IL equal to IA plus I shunt. That is, the total line current is the summation of armature current and shunt field current. So this is shunt motor. Shunt motor can also be known as constant speed motor because it is mainly used for constant speed applications. That's why the other name of shunt motor is constant speed motor. So next one, compound motor. So compound motor is nothing but it is the combination of both series field and shunt field winding. That's why it is called compound motor. So in compound motor we have two types. One is long shunt, another one is short shunt. So in long shunt, what do you mean by long shunt motor? So in long shunt motor, the shunt field winding is connected